Hello everyone, in this video lecture we will try to understand what is Lagrange interpolation method. For that we must know what is interpolation first. Suppose we are given the following values of y with respect to some set of values of x. Then if we want to find out the values of y corresponding to any value of x between x0 and xn is called interpolation. We can see the application of interpolation in various forms, like we have estimated the temperature at 8 am, let it be 24 degrees Celsius, then at 9 am, which is 25 degrees Celsius, at 12 am, let it be 30 degrees Celsius, at 4 pm, let it be 27 degrees Celsius, and after that we have directly calculated it at 7 pm, which is again 24 degrees Celsius. And we want to know what was the temperature at 2 pm is called interpolation. But if we want to find out the temperature at 9 pm, which is outside the range of x, then this method is known as extrapolation method. So we can say interpolation is the technique of estimating the value of a function for any intermediate value of the independent variable, while the process of computing the values of the function outside the given range is called extrapolation. And if we already know the function f of x, then it is very easy to find the value of y corresponding to any value of x. But if the form of f of x is not known to us, then it is very difficult to determine the exact form of f of x with the help of this tabulated set of values. In these cases, we replace the function f by some simpler function, let us say it phi of x, which assumes the same values as those of f of x at the tabulated set of points. If we let phi of x as polynomial, then it is called the interpolating polynomial, and the process is known as polynomial interpolation. Similarly, if we take phi of x as finite trigonometric series, then we have trigonometric interpolation. But in this video, we will restrict ourselves to polynomial interpolation only. And in layman language, we can say interpolation fills in the gaps by drawing a smooth line between the known points, allowing you to estimate the value at any point in between. And the example we have already considered, we can see that in these two time intervals there is gap of 1 hour only, but in these two intervals there is gap of 3 hours, and after that there is gap of 4 hours and then 3 hours. There are various interpolating methods. For example, Newton's backward, forward, central difference, Gauss forward, Gauss backward, and many others. And one of interpolating formulas is Lagrange interpolation method. And this method holds an advantage that it can be used to find the values of the function even when the arguments are not equally spaced, like we have seen in this example. Now let us move directly to the Lagrange interpolation formula. Suppose the function f is tabulated at n plus 1 points, which are x0, x1, x2, so on to xn, and they are not necessarily equidistant. and the corresponding values of function f are y0, y1, y2, so on to yn. Let the function f is approximated by a polynomial as phi nx is equals to a0 into x minus x1, x minus x2, so on to x minus xn, plus a1 into x minus x0, x minus x2, so on to x minus xn, plus so on to an x minus x0, x minus x1, so on to x minus xn minus 1. Let us mark this as equation number 1. This phi n x will have a degree of at most n such that phi n x and f of x agrees at the tabulated points which are already given. So we can say that f of x is similar to phi n x and phi n x i's is equals to y i's for j is equals to 0, 1, 2, 3, so on to n. Let us mark this as equation number 2. Since we have considered that fx is similar to phi n x, now we will start putting the values of, here is I not j. Now we will start putting the values of I in phi n xi. So starting with I is equals to 0, phi of x0 is equals to y0, and we know that the value of phi n x0 will be a0 into x0 minus x1, x0 minus x2 into so on x0 minus xn. From here we can find the value of a0, which will be y0 divided by x0 minus x1, x0 minus x2, so on to x0 minus xn. In the same way, when we will use the value of I as 1, then the value of y1 will be a1 into x1 minus x0, x1 minus x2 into so on x1 minus xn. From here we can find the value of a1 as y1 divided by x1 minus x0, x1 minus x2, so on to x1 minus xn. In the same way, we can generalize this, where the values of an will be yn whole divided by xn minus x0, xn minus x1, so on to xn minus xn minus 1. Substituting these values of ai's in phi of x, it will be phi n x is equals to x minus x1, x minus x2, so on to x minus xn whole divided by x naught minus x1, x naught minus x2, so on to x naught minus xn into y naught, plus this polynomial is known as Lagrange polynomial or Lagrange interpolation formula. Now in this formula we have to notice one thing, that the coefficient of y naught will have all the terms subtracting from x except x naught, and in denominator we will just directly put the value x naught in place of x. Similarly, for the coefficient of y2 in the numerator, please make a correction here that this is y1 not y2. Now the coefficient of y1 will have all the terms subtracting from x except x1, and in denominator we will just directly put the value of x1 in place of x. Similarly, for the coefficient of yn, here again you have to make a correction, there is n minus 1. We have subtracted all the terms except xn from x, and in denominator we have just replaced the value of x by xn. Let us try to make an understanding of this method. We are given 4 points and their corresponding y value, and we can notice that the values of x are not equidistant. Let us write it in the form of table first, where the values of x are 1, 3, 4 and 6. The corresponding y values are minus 3, 9, 30 and 132. And we have to estimate a Lagrangian polynomial, and we know that Lagrangian polynomial will be in the form of, this equation will become, after simplifying this equation, it will become x cube minus 3x square plus 5x minus 6, which is the required Lagrangian polynomial. Let us try one more question. In this question, we have to find out a Lagrangian polynomial using the given data, and after that we have to find the value of f of 3. The Lagrangian polynomial for this question will still be same, and after putting the values of xi's and yi's, it will become x minus 1 into x minus 2 into x minus 5 whole divided by 0 minus 1, 0 minus 2, 0 minus 5 into 2. Similarly, the rest of the term will be, after simplifying, this will become x cube plus x square minus x plus 2. This is our final Lagrangian polynomial. Using this polynomial, we have to find out the value of f of x at 3. So, the value of f of 3 will be 27 plus 9 minus 3 plus 2, which is 35. Let us try some different question based on this method. The question says, using the Lagrange interpolation formula, we have to express the function as sum of partial fractions. The given function is which can be rewritten in the form of x cube plus x minus 3 whole divided by x minus 1, x minus 2 and x plus 1. And we consider the numerator as f of x, which will be x cube plus x minus 3. Now Now tabulating the values of f of x for the values of x as -1, 1 and 2. This is because we want to convert it in the partial fractions and the root of the denominators are clearly -1, 1 and 2. Therefore, the table will be -1, -3, 1, -1, 2 and 3. Using Lagrange formula, we can directly write the value of f of x as x minus 1 into x minus 2 whole divided by -1, -1, -1 minus 2 into -3 plus x plus 1 into x minus 2 whole divided by 1 plus 1, 1 minus 2 into -1 plus x plus 1, x minus 1 whole divided by 2 plus 1, 2 minus 1 into 3. After simplifying this term, it will be -1 by 2 x minus 1 into x minus 2. Please make sure that you are not simplifying these terms because we do not need the Lagrangian polynomial in the end. Rather, we want to convert it in the partial fractions. So, we will just simplify the denominator term and it will be half into x plus 1 into x minus 2 plus x plus 1 into x minus 1. This term is equals to x square plus x minus 3. Now we will divide both sides by x minus 1 into x minus 2 into x plus 1. That is, and we get x square plus x minus 3 whole divided by x minus 1, x minus 2 into x plus 1, which is equals to minus half of 1 upon x plus 1 plus half of 1 by x minus 1 plus 1 upon x minus 2. This is our required answer. I hope you have made an understanding of this interpolation method and you have a confidence for solving these types of questions. In the next video lecture, we will try to code Lagrange Interpolation Method in MATLAB. If you have found this video useful, don't forget to share it with your friends. Happy learning!